Hey guys, welcome back to another video, and today I'll be talking about two topics of discrete mathematics. One is modular arithmetic and another one is Cesar cipher. So both are really easy topics, and the final one is really interesting. So let's get into it. So first we'll be talking about modular arithmetics here. So this is a really easy topic, and first I'll be going through the basics, and then I would help you understand how to tell time in a 24-hour clock, and we'll be building our own 6-hour clock. So let's get started. So suppose the question says you have to mod a number. Let's say the number is m, and you have to find modular arithmetic of m with respect to n. So the result would be the remainder if you divide m with n. So let's look at an example so to become more clearer. So let's say the question says 8 mod 3. So what would that be? So we try to divide 8 by 3. So let's look at here. So it would be 2, 6, and the remainder would be 2. So this remainder, this is the answer of that question. This would be 2. So let's look at another example. So 15 mod 4. So what would this be? So this would be 3. So this is basically it of modular arithmetic. So there's one exception. Suppose they tell you to 8 mod 9. So in this case, if you try to divide 8 by 9, you would get into some floating points value, right? Something 0 point something would appear. So in this case, we never go to the 0 point something, because we always look at the remainder, and the result here at the right hand side would always be a decimal number, not going into a floating number. So here the modular result would be 8. So always remember that if you have if the number n here is much greater than the m which is here, then the result would be always m. Otherwise it would be the remainder that you get. So this is basically it, and now we would be going into what I said, the 24-hour clock system. So how do you tell time in 24-hour clocks? So suppose someone says it's 1500 hours, right? So what does that mean? So we use modular arithmetic here. So we divide 15 by 12, and the remainder would be 3. So it's 3 p.m. Concept of AM PM comes from if the m value is much greater than the 12-hour system that we are talking about. So if m is greater than 12, then it would be a PM. And if it's less than 12, it would be an AM. So let's say it's 10 AM. So if you use the 12-hour system and use modular arithmetic, so it would be 10 mod 12. So as I said, m is much lesser than n here, so 10 would be the result. So it's 10 AM. And again, if you look at another example, let's say someone says it's 1800. So how do you convert it to a 12-hour system? So 18 mod 12, so that would be 6 p.m. So if you have understood this, the next example would be easier for you, and I would request if you try to do this by yourself. So the question here is, make your own 6-hour system. So hope you guys tried it, and let's try to uh, make this by ourselves. So let's say from 0 to 5 it's AM, from 6 to 11 it's, let's say it's a day, so DM. And from 12 to 17 it's like midday, so MM. And from 18 to 23 that would be normal PM. So this would be our system. And if someone says it's 1500 hours, so 1500, I wrote wrong, so 1500 hours. So how do you define in which time does this fall in our 6-hour system? So this would be 15 mod 6, which would be 6 into 2, 12, and say 3. So this would be, in this place it's 3 mm. So hopefully you guys did understand modular arithmetic, and it's quite fun, to be honest, and really an easy concept. So next up we'll be discussing about Cesar cipher. So finally coming to the most interesting topic of today, which is Cesar cipher, not to be confused with a Caesar salad. Both are completely different things. So if you are a CS student, you would have definitely heard about encryption and decryption. Well, nowadays you don't need to be a CS student to understand that. You can see that in movies people are doing encryption and decryption of passwords and stuff. So we would be looking at a really basic encryption decryption technique. So this was invented by Julius Caesar. He was a Roman dictator, and it's one of the simplest and most widely known encryption techniques. So this would help you to get used to encryptions and decryptions, and get you to understand and get you more interested in these topics. So how did he do it, and why did he do it in the first place? So whenever he needed to send any information or any confidential information to anyone, so he used to use this cipher technique. So how did he do it, and how can we do it? So let's have a look. So suppose you want to encrypt something. So you write the alphabet similar to this. You write A, B, C, D, and in your question paper you would also do the same. You would write all the alphabets, and suppose it would say you on how many it would give you a number basically. This is the number, and based on the number you would be changing the position of the alphabets. So in this case it says 3, right? So we would be shifting 3 here. So always start from the right hand side. So it says 3, so 1, 2, 3, right? So we put A here, B, C, and move on, and finally to up to Z here. This is the text you would be encrypting to send it to your another general. So how do you do this? So you write down all the words, right, like this, similar to this. You write down all the words, then you look at the changed alphabet sequence. So first of all it's D, right? So we put D, W here, and R, so we put U here, and similar to this you come up with an encrypted message. So finally you did get the encrypted message, right? But how do you decrypt it? So again, let's write down the whole alphabet. So we have finally written all the alphabets here in the normal sequence. now let's say your friend tells you that the code is p plus 3, right? So when we are doing encryption, we start from the right hand side. So 1 2 3, remember, 1 2 3, and we at the 3 point we start our A B C. In this case you'd be putting a, so you'll be counting 1 2 3 and putting A here, A B C D E F. So this is the new sequence that you get. So remember, this is the key here. When you're doing encryption, you start from the right hand side, and when you're decrypting, you would be starting on the left hand side by skipping one more character. So here we did 1 2 3 and we didn't write A here, right? We skipped this and wrote A here. So now let's try to decrypt the message that we got. So this is the one that we have to decrypt. So let's see. So it says W, so means T. It says U, so R. H, so K. Oops, H, so E. So E, says D, so A. So you get the point, right? So from this you can decrypt the encrypted message. So this portion is really important for you guys to remember. So for encryption you would be looking at the right side, and on the nth value you would be putting A, and for decryption you would be looking at the right side and putting A at n plus 1 value. This that we did here. Okay guys, that's all for today, and hope you guys did like the video, and if you have any questions, comments, feel free to put it down below. And I'm trying to improve the videos by putting like a title screen and a ending screen. I'm not really good at it, but I'm trying. So hope you guys like the videos, and of course do let me know what your comments are and what your suggestions are. So thank you.